All right, everybody, Professor Clark back here with our next math. Today we're going to be looking at our hip rafters, our valley rafters. Okay, but before we do that, we're going to review our quiz. Okay, everybody can see that I put our the questions on the quiz up here. And again, if you handed it, if you sent it to me, you got credit for it. Okay, many of you did it wrong. I looked at the quizzes. Many of you did it wrong, but that's okay. We'll explain it through this process. But again, understand you guys got credit for it just by handing it in. Okay, and that's true for everybody that handed it in. All right, so looking at this, what do we say here? Unit run of a common rafter. Okay, we've talked about this a bunch of times. Is always 12 inches. Okay, always. Unit run of a hip rafter. Okay, I'm going to answer that one last because that's what we're going to be looking at today. Okay, so going down to number 3, total run. What did I say the total run always is, except in the case of jacks? It is always 1/2 my span. Always. Okay, and what is my span? My span is the width of my building. Okay, so no matter what rafter I'm talking about, except for jacks, okay, whether it be a common, a hip, a valley, okay, it does not matter. The total run is always 1/2 my span. Okay, so looking at our quiz again here, or looking at our print, I should say. Okay, common number 1. Common number 1 is right here. Okay, the width of the building is 24 feet. So my run is 1/2 my span. It's 12 feet. Okay, hip number 2. I look at hip number 2 right here. Okay, the width of my building is 14 feet. Okay, so my run is 7 feet. Valley number 1. Okay, valley number 1 right here. Okay, everybody sees it. The width of my building is 24 feet, so my run is 12 feet. Okay, we'll skip the jack for now. Okay, common number 2. Look at common number 2 right here. Okay, these commons right here. The width of my building is 14 feet, so my run is 7 feet. Okay, hip number 1. Okay, and I know yours said hip number 2. That was a typo on my point, or on my part, but don't worry about it. I meant to say hip number 1. Hip number 1, okay, hip number 1 right here, 24 feet, so my run is 12 feet. Okay, my run is always 1/2 my span, except for jacks. Okay, so no matter what, my run is going to be usually an even number. Okay, but it can be feet and inches, I guess, but still, it's 1/2 my span. Okay, and you might be asking, well, how can that be? Because I look at my hip and I look at my valleys and I can see that they're significantly longer than my commons. Okay, and you would be correct in asking that question. Okay, that's what we're going to talk about today. And that's because, and I will show this through the math, the unit run of my hip is 16.97 inches. Okay, I told you that my unit run of my roof, okay, and therefore my common rafter is always 12 inches. And it is. Okay, my roof, no matter where I measure on that roof, I'm going to measure 12 inches of unit run, okay, and I'm going to find whatever my unit rise is from there. So if I'm an 8/12 pitch, if I measure over 12 inches horizontally, I'll measure down 8 inches vertically. If I'm a 10/12 pitch, I'll measure over 12 inches horizontally. I'll measure down 10 inches vertically. And again, that does not matter where I measure on this roof. I can measure right here on the hip side. I can measure right here on the common side. And my unit run for that roof is going to be 12 inches. Okay? And it's always going to be 12 inches for my common. Okay? It's also always going to be 12 inches for my jack. Okay? It's going to change when I get to my hip or my valley. It's going to be 16.97 inches, and I will demonstrate that in a minute on the board. Okay, and that's because this rafter and this rafter hit my top plate at 90 degrees. This rafter and a valley rafter hits my top plate at 45 degrees. Again, I'm going to go through all of that math in a minute here. Okay, but again, understand that the unit run of my roof is always 12 inches. The unit run of my common rafter or my jack rafter is always 12 inches. the unit run of anything that hits the top plate at 45 degrees, or my hip or my valley, is 16.97 inches. Okay, for a jack, okay, for jack number 1, my unit run is 2 feet. Okay, and I will explain that in a few minutes too. That's because my on-center spacing is 2 feet. Okay, but we will get to that as we walk through the math. All right. So again, everybody got credit for their quiz as long as you gave it to me. Okay, and again, hopefully everybody understands now what my total run is. Okay, my total run. Again, this is why I wish I was with you guys. I could get a feeling for that quite a bit better. Okay, and we would demonstrate that down in the lab, but because of what's going on, obviously we can't do that. Okay, but again, what's important here is understanding this. Okay, it's always, my run is always half my span. Okay, and then understanding these 2 unit run when I'm dealing with different types of rafters. Okay, again, understanding that the unit run is always 12 inches for my roof, but that's not necessarily true for my rafters as I'm building that roof. Okay, again, I'll demonstrate that in the math as we move forward. All right, so again, taking one portion of our building, just working with one shape. Okay, we will look at our hip and our commons and our jacks once again. Okay, so I would recommend that everybody sketches this out on a piece of paper as you're following along so that you can go back and review the information. Okay, I guess one nice thing about this is that you can go back and review the video at any time. Okay, and that's legit too. Okay, but since you're not getting much hands-on, I would recommend that you sketch this out to help you understand it. Okay, so again, my span is going to be 24 feet. Okay, we're using our example that we've been using all along. Okay, my pitch is a 7/12. Again, we'll continue to use that example. Okay, my overhang, I think we had what, 18 inches? Yep, 18 inches. And my on-center spacing is 24 inches. Okay, so again, we looked at the common last time and we said, well, that's pretty obvious. I can see that the horizontal run, okay, again, thinking about this in elevation, and I will draw it out in elevation in a minute, but this is why, another reason that this is no fun that we're not up at school, because I could draw them both on the board. I could draw it in plan and elevation if I had enough room on the board, but I don't. Okay, so you guys can see this, so I'm going to have to do it separately. But again, for my common, I can easily see that my run is half that span. Okay, so I can easily see that half that span, my total run, is going to equal 12 feet. Okay, well, I told you that for my hip number 1, the same thing. My total run is going to be 12 feet. Okay, and again, you ask, well, how can that be? Okay, because like I said, my hip is obviously significantly longer than my common, and you would be correct if you said that. All right. Okay, so now what we're going to do in order to demonstrate that is we're going to make our unit run into a square. Okay, so if I have 12 inches right there, I'm going to say that I have 12 inches right there. If I have 12 inches right there, I'm going to say that I have 12 inches right there. If I'm going to say that I have 12 inches right there, I'm going to say that I have 12 inches right there. Okay, so if I have 12 inches right there and we have a 7/12 pitch, if I understand that in elevation, okay, or vertically, I understand that for every 12 inches of that box, I have a vertical rise of 7 inches because that's our pitch. Okay, that's been defined for us. All right, well, I can take this same box and I can superimpose it on my hip. Okay, so I can say that that's 12 inches and that's 12 inches. Okay, so if this is the unit run of a common rafter, okay, right there, that 12 inches, Okay, now superimposing that box, that pitch box onto my my hip rafter, I can see that now my unit run becomes the hypotenuse of that 12 by 12 square. Okay, and so what is the hypotenuse of that 12 by 12 square? Okay, everybody can get out their calculators real quick. So again, I took a box and I superimposed it onto from my common rafter to my hip rafter, and I see that my run now becomes, my unit run now becomes the hypotenuse of that 12-inch by 12-inch box. Okay, we know we can solve for that using the Pythagorean theorem. A squared plus b squared equals c squared. So c squared equals 12 squared plus 12 squared. So c squared equals 144 plus 144. So c equals the square root of 288. Okay? All right, and again, that's in inches. Okay, all of those are in inches. Okay, so if everybody does that on their calculator, they will determine that equals 16.97. Okay? So 16.97 inches. Okay, so again, what I'm saying is that I've taken that box, I've established a box on my common rafter, and then I've superimposed it onto my hip rafter or my valley rafter, basically any rafter hitting the top plate at 45 degrees, and I've determined that now my unit run becomes the hypotenuse of that 12 by 12 triangle. Okay, so for my hip rafter, I would say 7 over 16.97. And now thinking about the math that we walked through last time, obviously by changing that number to 16.97, that's going to make the A length and the B length of my rafter significantly longer. Okay, and we will walk through that. I will also show it to you in elevation. Okay, so I'm going to attempt to put both of them on the board. Hopefully you guys can see it, even though it's significantly smaller than I'm used to. Okay, so again, 24-foot span. I can easily see that the unit or the total run of that rafter is going to be 12 feet. And I can say, all right, I'm going to create a box, a 12 by 12 box instead of a triangle. I'm going to superimpose that box onto my my hip rafter. I know it's a 12 by 12 box, and so now I can graphically see that that is my unit run for my hip rafter. Okay, so looking at that in elevation, what we're saying is that as I move across this triangle, okay, if this is a common, I know that's 12 inches and that's 7 inches. That's 12 inches and that's 7 inches. That's 12 inches and that's 7 inches. If this is a hip, I know that that same box becomes the bottom leg of that triangle, and so the bottom leg is now 16.97, and my vertical rise is 7 inches. 16.97, and my vertical rise is 7 inches. So again, as we go through the math, I should be able to see that all I have to do is solve for the hypotenuse of that triangle. Okay, and now I know that that's going to make my numbers bigger, which means that my rafter is going to be longer. Okay, we can look at it on our quiz right here, or actually, everybody go back to our handout right here. Okay, so again, I can see that I can say 12 inches of horizontal run equals 7 inches of vertical rise on this common, and if I take that same box and transfer it over to here, I can see that the 12 by 12 box, the hypotenuse of that triangle becomes 16.97, so 16.97 inches of vertical or of horizontal run and 7 inches of vertical rise. Okay, hopefully that's making sense to everybody. Okay, another way that I demonstrate it, you have to give me a second here to get my little prop in place. Another way that I demonstrate it is with this little prop that I use. Okay, Okay, I have this up at school. Okay, I'm gonna take this prop. Okay, this is not looking great, but hopefully everybody sees it. Okay, I'm just showing you some different angles of this prop. And what is this? It is a little hip rafter mock-up, okay, for your use so that you guys can see it. Okay, hopefully this makes sense to you. Okay, everybody can see it. Okay, so right here I've got a common rafter. Everybody should be able to see that common rafter. And then right here I've got a hip rafter. Okay, all right. So let's see how this works. So with my common rafter, I've got a piece of paper right here that I made. Okay, and we're saying that that's a 12 by 12 box. Okay, I would measure 12 inches by 12 inches. If I look at my common rafter, okay, everybody should be able to see that. I can say that if I go over horizontally 12 inches, I know I'm going to come up vertically 7 inches. Well, if I do the same thing to this hip rafter, I take that square and I transfer it over to here. Okay, everybody should see I'm now hitting the hypotenuse of that triangle. Okay, and again, we know that's 16.97, and then I would have 7 inches of vertical rise. All right. So again, hopefully that is making visual sense to you guys now, okay? Because that's what I'm attempting to do here. And again, by cutting the rafter and building the rafter system, it makes a whole lot more sense, which is what you guys are getting robbed of this semester, okay? So even if it doesn't make sense right now, it will. It doesn't make total sense right now. It will as we start to move through the math, okay? So if nothing else, okay, keep noodling on it, keep trying to understand what we're talking about geometrically, okay? But even if it's not, just continue to do the math, and as you do the math more and more and more, it will make more and more and more sense, okay? And you do the math using the rules, okay? So the rule is, number one, if rafter hits top plate at 90 degrees, unit run equals 12 inches. Rule number two, if rafter hits top plate at 45 degrees, unit run becomes 16.97. Again, because it's the hypotenuse of that 12 by 12 triangle. Okay? So again, hopefully everybody is understanding that geometrically. If not, as we continue to do the math and you continue to study the prints, okay, looking at each print that I give you, each little roof plan, okay, hopefully that will start to make more sense. Okay? All right. So that means we can move forward with some more math. All right, so going back to our handout, okay, again, we've got a roof line. Okay, everybody refer back to this. We've got a roof plan. Okay, and again, we see that our span is 24 foot. We know all of our other criteria up here. It's a 7/12 pitch, 18-inch overhang, 24 inches on center. Okay, all right. So looking at that, now I can start to solve for more of those rafters. Okay, so we already solved for the common, but we'll go ahead and do it again. Okay, and first off, we'll go ahead and draw our rafter. And we'll solve for our common one more time. Okay, we've already done it once, but we'll do it again and then I'll start changing some numbers. Okay, what are we solving for? We're solving for our A and our B dimension. Okay, what are we saying? We're saying that if that common hits the top plate at 90 degrees, I know I've got 12 inches there and 7 inches here. Okay, I know I've got 12 inches there and 7 inches here. Okay, again, we're going to solve for the hypotenuse of that triangle. We've already done that once. Okay, so again, what are the four things that I need? I need A, B, C, and run. If I'm solving for common number 1, my run is going to be what? 12 feet. If I'm solving for something that hits the top plate at 90 degrees, my unit run is going to be 12 inches. My unit rise is going to be 7 inches. I solve for the hypotenuse of that triangle. That's C. Okay? So C equals A squared plus B squared. We've already done this once. So C equals 7 squared plus 12 squared. So C equals 49 plus 144. Okay, so C equals the square root of 193. So again, we saw that C equals 13.89 inches per foot. Okay, and if you remember, we talked about the fact that I can see that on my framing square. Okay, length of common rafter per foot of run. I go to my 7. I read underneath that. Okay, where's my 7? Right here. And I see 13.89 inches. Okay. All right, so I've got 13.89 inches per foot. Okay. Then I solve for my A and my B dimension, knowing that A equals C times run and B equals C times overhang in feet. Okay, and by the way, those will never change. That'll always be how I solve for my A. That'll always be how I solve for my B. What will change? This will change. 12 inches. Okay, and again, like I said, we're talking about the rafter, not the roof. Okay, so again, common rafter, jack rafter, my unit run is going to be 12 inches because it hits my top plate at 90 degrees. Hip rafter, valley rafter, we already showed that that's going to change to 16.97 because it hits my top plate at 45 degrees. Okay, that's really the rule that we're going to use. Okay, so 13.89 inches per foot times my 12 foot. Okay, equals, my feet are going to cancel. And I'm going to get again, everybody should be doing this with me, not just watching me do it. Okay, you should be doing it on your calculator. Okay, equals 166.68 inches. So I have to divide that by 12 inches per foot to get it into feet and inches. So I divide that by 12. I get 13.89 again. Of course I do. Any of you who are really getting the math. So 13 feet, 0.89 times 12. 10.68, okay, 0.68 times 16, because I want it in sixteenths, gives me 11 sixteenths. So 13 foot, 10 and 11 sixteenths. Okay, then I solve for my B. Again, the key there is that my overhang has to be in feet so that my feet will cancel. So 18 divided by 12, 1.5 feet. Okay, my feet cancel. So 13.89 times my 1.5, I get 20.835 inches. I divide that by 12. I get 1 foot. 0.736 times 12, I get 8 inches. 0.832 times 16, I get 13 sixteenths. So 1 foot 8 and 13 sixteenths. So 1 foot 8 and 13 sixteenths. Okay? All right, so now we look at our hip. Okay, so we look at our hip. What do we see in elevation? Okay, it looks exactly the same, doesn't it? Okay, looks like a triangle to me. Looks like a big triangle. Okay, I can't tell any difference from my hip to my valley. I'm sorry, my hip to my common. Okay, in this graphic representation, I see it as a triangle. Okay, going back to my common here, okay, my common number 1, what do I see it as in plan? I see it as a square or a rectangle. Okay, how about my hip right here? What do I see it now as in plan? I see it as another triangle. Okay, so that's the difficulty with a hip or a valley, is that I'm understanding it in plan as a triangle and elevation as a triangle. My common, I'm understanding it as a square in plan and as a triangle in elevation. Anything hitting the top plate at 45 degrees, it's a triangle both in plan and elevation. Okay? All right, so again, that's the geometric aspect of it. Okay, so therefore, I can understand that bottom leg of my triangle becomes 16.97 because it's the hypotenuse of that 12 by 12 square. Okay, so 16.97, 7 inches of vertical rise, 16.97, 7 inches of vertical rise, and again, across that horizontal span, okay, my total run, I've got 12 of those triangles. Okay, so that's my common number 1 right there. Okay, for my hip number 1, A, B, C, and run. Again, my run doesn't change. It's still 12 feet. My total run doesn't change. Okay, my unit run changes, which is going to change my C. Okay, so now I see this, 16.97 inches and 7 inches. Okay, so again, I can see that all I have to do is solve for this hypotenuse, knowing that I have 12 of those unit triangles running across the horizontal span of that hip. Okay, so A squared plus B squared equals C squared. So C squared equals 7 squared plus 16.97 squared. So C squared equals 49 plus 287.981. And it's only because I've done it a million times that I have that number memorized. Okay, 0.981, 6, 12, 13, 336.981. Again, everybody should be following along on your calculator. So go ahead and find the hypotenuse of, the root of 336.981. And your calculator should tell you that it is 18.36. And again, we know our units are inches per foot. So my C is 18.36 inches per foot. So 18.36 inches per foot. Okay. And again, you saw me look at my framing square because now I see that the second row down has different wording, and it says length of valley or hip rafter, length of hip or valley rafter per foot of run. And again, what number am I going to read under? From a unit triangle standpoint, I'm going to read under my 7 because that's always the change. And I can see that I've got 18.36 inches per foot of run. Okay, so again, hopefully everybody's understanding the geometry that we're talking about here. The different big triangles, okay, that we're dealing with, okay, whether that be in plan or elevation, and the effect that that has on my little triangle or my unit triangle. Okay, hopefully everybody sees that geometry. If not, just follow the rules. Okay, and if you don't completely understand it, just follow the rules. The rule is anytime that a rafter hits the top plate at 90 degrees, my unit run is 12 inches. And second rule, anytime a rafter hits the top plate at 45 degrees, my unit run is 16.97. Okay, struggle, noodle, keep thinking about it until you understand the geometry, because that's really what's important, understanding the shapes that we deal with in construction. Okay, but until then, if you need to, just apply the rules and follow along accordingly. Okay, all right, so now I can solve for my hip. Okay, because I've solved for my different C dimension. Okay, so again, going back to our formulas, this is where it gets easy. All I have to do is plug my numbers into my formula now. A equals C times run, and B equals C times overhang in feet. Okay, super easy. Okay, you guys have heard me say it a million times. Okay, math is not the ability to plug numbers into a formula. Anybody can do this. It's super easy at this point. Okay, math is the ability to set the problem up. okay, to see what needs to be solved for, to understand the geometry, to understand the algebra as it relates to our geometry. Okay, from there, we can solve for anything because we can see what needs to be solved for. Okay, but again, from here it's easy. All I have to do is say my 18.36 inches per foot times my 12 foot. Okay, so we walk through that. Again, you guys should be following along on your calculators. My feet cancel, so I know that I get 220.32 inches, and I need to put that into feet and inches. So I divide by 12, I get 18.36 feet. Okay, that means that I have 18 full feet and 0.36 increments of a foot. So I multiply that by 12 inches per foot. My feet are going to cancel. I get 4.32. That means that I have, and my units are inches, so I have 4 full inches. I need increments of an inch. I want them in 16ths, so I multiply by 16. And I get 5/16. Okay, so my A is 18 foot 4 and 5/16. Okay, inches. Okay, again. Likewise, I'm going to walk through and plug my formula or my numbers into my formula for B. So C is my 18.36 inches per foot times my 18 inches in feet, which is 1.5 feet. My feet are going to cancel, and this time I'm going to get 27.54 inches. So again, I need that in feet and inches. So I divide by 12. I get 2.295 feet. So that means I have 2 feet and a portion of a foot times 12 inches per foot. Feet cancel. Is 3.54 inches. So 3 inches and a portion of an inch. And again, I want that in fractional increments of 16. So I multiply it by 16. And I get 9/16. Okay, so 2 foot, 3, and 9/16. Okay, all right, so again, understanding what we've talked about today. The geometry tells us that when my rafter hits my top plate at 90 degrees, my unit run is going to be 12. Okay, so I have to solve for that unit triangle. First, I have to determine my total run, which is always half my span. Then I have to solve for that unit triangle. I have to solve the hypotenuse using 12 and whatever my rise is. Okay, then the geometry also tells me that if my rafter hits my top plate at 45 degrees, I see that the unit run is now the hypotenuse of that 12 by 12 square, which is 16.97. Okay, so I have a bottom leg of 16.97 and whatever my rise is. In this case, it's 7 inches. Again, going all the way back to when we talked about slope, what are we talking about? They're defining the slope for us. Okay, so 16.97 over 7, I solve for the hypotenuse of that triangle, knowing my run, and from there, I can solve for the length of my hip. Okay, and obviously significantly longer than our common was. Same thing with my tail, significantly longer than my common tail was. All right? Okay, so that's how we solve for our hip. And so again, what does that mean? That means that my A dimension is from here to here. Okay, and that's 18 foot 4 and 5/16. Okay, and my B dimension is 2 foot 3 and 9/16, and that is from that point to the end of my tail. Okay, so again, hopefully you guys understand this. Okay, you're not getting the benefit of being able to lay it out. Okay, that really helps with the geometry. It gives you a much better understanding of it. But we can't do that, so it is what it is. All right, I am planning on putting together a video of laying out rafters. Okay, so you could get ahead of the game before everything closes down, if that is going to happen. And you could grab a framing square from one of the lumber yards. If your dad has a framing square, if you have a framing square, if your mom has a framing square already, if somebody already has one, that's fine. You can use theirs. But if you want to follow along with me when I lay those rafters out, like I said, I'm going to create that video. I would recommend that you go grab 4, 5, 8-foot 2x4s. Again, I cannot require that. That's a part of your lab fees or a part of your tuition that pays those lab fees, and I obviously provide that stuff for you in the lab. But again, I'm not able to do that. So for those of you that want to learn that and want to follow along with me on that video, I welcome you to and invite you to. But if not, again, we are obviously not going to have our final exam, which is a hands-on layout. We are only going to do the math. Okay, so that puts us back to here. If you understand what we've talked about so far, okay, which is, and again, at worst case scenario, if you at least can remember the rules, anytime a rafter hits the top plate at 90 degrees, my unit run is 12. Anytime the rafter hits the top plate at 45 degrees, my unit run is 16.97. From there, you can solve for your A length and your B length using your two formulas, A equals C times run and B equals C times overhang in feet. Okay? All right, so hopefully everybody enjoyed this video. I will be emailing you your next quiz. Understand that normally that's a week process. So in our case, what did we have? Mondays and Wednesdays. So on Monday would have been lecture, okay, and I would have walked through this math on the board, and on Wednesday you would have taken a quiz. Okay, and the following Monday I'd go over that quiz, and then following Wednesday you would have taken another quiz, and on until we got through all of the math. Okay, so obviously we can't do that. So this is the only video that you're going to get this week, okay, and then I'm going to send you all an email with a quiz attached, and again, complete that quiz. Scan it and send it to me, and again, you will get credit for it if you complete it. And then my next video will be us walking through the quiz that you are going to receive. All right, so hopefully this is doing some good. Hopefully you guys are at least getting the math. That's my biggest concern. Okay, that's what's most important. Okay, most of you will not actually be carpenters and go out there and actually do the work. What's important is that you understand the math that we deal with in all areas of construction. So, all right, so hopefully everybody's doing well. Stay strong, and let's try and get through this, and hopefully everything will be better soon. Okay? All right, thanks everybody. Have a good day.